Hello, my name is Rich Howard, owner of Architectural Builders Supply. This video is to bring you a closer look at the Adams Rite number 7100-515-628. This is an electric strike. It's possibly 7100 is possibly the most common electric strike there is. An absolute regular item when it comes to aluminum storefront. Let's do a visual tour of everything that's in the box first. Obviously, first, the business end, the 7100. This is going to have a faceplate that's ideal for aluminum storefront, meaning that it has a radiused corner. Why is that ideal? Well, when it comes to aluminum, they're literally going to route with a router and a carbide router bit when they are prepping for hinges or strikes or, you know, overhead stops or electric strikes as well. And that's going to leave a radiused corner. They're not going back in with a file to square those corners out. So a radiused corner strike is very typical. Obviously, this is a fail-safe strike. I don't recall the 515 in the part number. Obviously, it's fail-safe. Let's do some dimensional properties of it, then we'll talk about why you might be looking at this. This is going to be a typical 4 7/8 overall height. That's not necessarily something mandatory for aluminum storefront, but it is a typical height for hollow metal frames. And the bottom line is you could use this in a steel frame as well, but you'd want to use a different faceplate. The overall width of the faceplate, 1.25 inches. Okay, this is going to be ideally suited for cylindrical type locks or Adams Rite type aluminum storefront latching hardware that has a particular projection of latch. This is not going to work for something with a 3/4 projection. What else is in the box is your mounting tabs. If you're doing a new installation, you'll need these mounting tabs. Take them out of the package. And basically what happens is you will create the preparation in the frame. You're going to drill a hole. You'll countersink that hole ever so slightly, and then you're going to attach the unit, the mounting tab, directly to the frame, and then you'll bring your strike up to that installation is what that's going to look like. Something like that. Okay, you'll get a handful of shims that are in here. There's going to be fasteners for attaching everything. A couple of wire nuts as well. This has just 2 wire leads, which makes sense. There's only power going to this. There would not be any additional wire leads because there's not any other electrical features to this strike that would require more wires, such as monitoring would require. Door position switch would require more wires as well. Now, let's talk about why you're looking at this. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, I would think that you're looking at this because you need an electric strike, is the bottom line. This client, and these are going to, we're shipping these to Asia, in fact, to Singapore, and there are 6 of them, and this client also ordered the rectifiers, the transformers, power supply. Well, transformer. It's a transformer. They've got a DC strike. They've got a 4605 transformer, and then they've got a rectifier. So it's an AC transformer. Then they're going to rectify it to make it run with a DC strike, and that's clearly what they want. Why would they want a DC strike? They may not want a buzzing sound when it is activated, and this being fail-safe, when this is energized to keep it locked, it would buzz continuously. That's what AC does. So they've got a DC strike because they want it fail-safe, meaning in the absence of power, it is unlocked, is the bottom line. So that would make perfect sense that they would have a fail-safe strike and want it to be DC voltage. What I'm trying to say is, because they want fail-safe, where it has to be energized to be locked, they would want DC voltage because DC voltage does not buzz when it's powered. Otherwise, it would be buzzing all the time if they had AC voltage. So they've got an AC transformer, the 4605 by Adams Rite. They've got a rectifier, which basically means you can connect DC units to an AC power source and convert that wave so that it's compatible with the DC requirements of the strike. What happens with this 7100 is this is a platform of a pretty typical strike, and you can swap out this faceplate. There are different types of faceplates. One's for wood frames, hollow metal frames, aluminum frames like this. This client also ordered the lip extension, and that lip extension is literally going to go here. It's going to go onto this area here where they clearly have the need of their latch bolt not hitting the casework or frame or trim prematurely. So they've got an 1.5 inch extension, so this piece of black, the lip portion of the strike, is going to be extended. So they've got some sort of unusual circumstance. Not unusual, but they have a circumstance where they've ordered all of those line items. And then again, your mounting tabs, that's pretty easy stuff. That will come with, the mounting tabs will come with the strike. They're assuming that you're doing a new installation, obviously. If you are doing a retrofit, I would suggest that you keep the mounting tabs. Someday you might need them. If you're a locksmith, you're definitely going to need them at some point. So let's now switch to the screen view and let's look at all the supporting documentation. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, let's take a look at the supporting information for this strike. First, some photographs that we have. These are linked to down below. Just different perspectives on this item. The label, very common for a client to email that to us. That's good. That tells us everything about what we're doing. This is, of course, continuous duty because it's fail-safe. It would only be powered. It would only be locked when it's powered, so it would need to be continuous duty. Profile. The edge of it would be nice. Probably be more appropriate if that was rotated. Then your fastener package. Got a couple of wood screws there. The fact that it's compatible with aluminum, it would also be compatible with a wood frame as well. There's nothing about this machining that would be problematic for a wood frame. The point I'm trying to make is whether it be a wood frame or an aluminum frame, you probably wouldn't go back and square out those corners, even though in a hollow metal frame you'd have square corners. Couple of nuts are here as well. That's going to be to secure the mounting tab into the frame. And then these wire nuts, obviously. Okay, let's take a look at the item itself. Extended description information. Used with AR dead latches, cylindrical latches for aluminum jams. Equals to 7800 and 7840. That's just different models of electric strikes by Adams Rite. This is considered a grade 1 strike, which is the most stringent of all ANSI standards. It has been tested to 1 million cycles and found to be compliant with that duty rating. Remote electrical control of any door equipped with an Adams Rite Series 45, 47, 49 or similar dead latch or key-in knob sets. Extremely compact mechanism, fits into aluminum jam or opposing door. If you have a pair of doors, it would fit into the door itself in sections as shallow as 1 5/8 inches. So if you have an aluminum storefront, your jam profile must be 1 5/8 inches. Electrical activation unlocks strike jaw or the keeper, releasing latch bolt so door can be opened without operating latch itself. Sure. So something here that they may not call attention to. The projection of the latch bolt that's going to go into the keeper would be considered 1/2 inch. And what that means is if you have a projection of a latch bolt that is 3/4 inch, like you would have on a mortise lock most commonly, or a cylindrical lock that has a fire latch, meaning they make latch bolts for cylindrical locks that are 3/4 inch projection, and that is typically used in fire-rated openings, especially pairs. What I'm driving at is the projection of your latch bolt it might be 5/8 with this, but 1/2 inch is certainly what you're going to count on. You can't have too much of the latch sticking into the keeper because the latch will not fully extend because it's too long for the depth of the keeper, rendering the lock not predictable and reliable in terms of its function. And that's what they're saying here. Key-in knob sets. There's not going to be a 3/4 inch latch projection necessarily for a knob set, even though there are, I'm sure that there are. You're going to want to keep it to standard material, not a mortise lock. Is what they're saying here. They're saying this is what you can use it with, and if it's not listed here, it's not compatible, or double check is the bottom line. Now let's take a look at our extended description information. The lip extensions, this client did order 6 lip extensions. That's just a condition of the wall or the frame. If you have something odd happening where you might have a frame and you have your electric strike, well, what if they come in and they do some sort of treatment to the face of the wall? When your door comes to close, the latch is going to hit that first. So you'll do a lip extension to prevent the bolt from the lock from hitting the jamb or the wall, whatever is there, prematurely. So it'll hit this metal and then slide up to the keeper. The rectifier, we talked about that earlier. The transformer we did as well. This transformer is rated for the amperage that this strike requires. The 4605 is, so it would work perfectly. Now, let's take a look at parts and accessories info. Okay, this is a document that just shows other options of this material. They can do monitor switches here if you need to know the condition or the state of the latch bolt. You need to record that or write that back to access control. They've got different transformers that are here. 4605 can go to 12 or 24 VAC. The 4606 is just 24 VAC. I don't even know if the 4606 is still available. The 4605 will have 3 legs on it, 3 terminals, and you just pick 2 of the 3 to get your voltage. So that's a handy document. Allows you to look at the part numbers for the different extensions that are here as well. Instructions. This is in the box. Okay, there's a lot of information here. Let's just take a look at it. First of all, they're showing you what prep you need to make in your aluminum frame. Here's the size. This is where everything's going to be mounted. The center line is going to be the same center line as your latch bolt, the center line of the latch bolt. That doesn't mean you're referencing that same dimension from the top of the door or the underside of the header. Account or adjust for that. If you're, if the top of the door to the center of the latch was, 40 inch, and you measure off the jamb, you're going to need to add 1/8 of an inch for that. But when you're dealing with a 4500, the template may not give you the center line of the latch directly. Let's take a look if I have a template for the 4500. It's always dangerous doing this live. Here's a 4920, which this would be compatible with. Template, that's for the exit device. Not sure why we're looking at that. Let's go to the manufacturer's page and we'll pull up that template. $49.20. Heavy duty latch. Documents. Okay. So here, okay, so the bottom line is they do give you the information that you need, just not directly. You're going to need to account for the center line of this latch. And how are they giving that to us? They reference the center line of the cylinder. And we've got a center line of the cylinder over here. Okay, so you do have to do some gyrations. You got 2 1/8 of an inch from the top of the prep to the center of the cylinder. And then you've got 1 7/16. They don't indicate it's the center line, but I think we can agree that it's the center line. So you've got 2 1/8 to get to the cylinder, another 1 7/16 to get to the center line of the latch bolt. Which means if that latch is at 40 inch from the top of the door to the center line, coming up with the center line of the strike face is going to be a matter of... And we can take those dimensions and determine that our relocation of center line is going to be 3/8 of an inch. And I realize here that they have it, but how do they get to this? Well, you've got 8 inch overall height here. And if you subtract 2 1/8 top of the prep to the center of the cylinder, and then another 1 7/16 from that 8 inch, that's 4 7/16. They're clearly, and half of 8 inch is going to be 4 inch, so we would remove that. That relocation of 3/8 of an inch would be exclusive of measuring from the underside of the header as well, if you're going to measure that dimension. So what I'm attempting to drive at is if our center line of latch is 40 inch, I'm going to put my tape measure to the underside of the header. I'm going to come down to 40 inch. I'm going to go up 3/8 of an inch for the relocation, but then I'm going to add 1/8 of an inch because assuming there's 1/8 of an inch from the underside of the header to the top of the door, I think in this math they have it as a 1/16 of an inch because 2 1/8 plus 1 7/16. Let's see, 2 1/8 plus 1 7/16 is 3 9/16. Which means to the center line of the latch body, or the center line of that strike, is going to be the difference between half of 8 inch and 3 9/16. The point of the matter is it puts you in that area of how you're going to determine where you're going to locate everything. But the bottom line is there's a 3/8 of an inch relocation from the center line of the latch to the center line of the unit. So again, if you go down to 40 inch, subtract 3/8, and that'll get you to the center line here. But you need to add, if you're referencing the underside of the header, you need to add whatever the gap is from the top of the door to the underside of the header, 1/8 of an inch or a 1/16 of an inch. That's how you would determine that. Okay, so back to our template. Shows us how we're going to prep everything. You will also note that they have the mounting tabs oriented in this position, the opposite of how I held it up earlier. And that's really going to be a reference to the offset of the mounting tab and then the thickness of the aluminum frame. So that offset, if this is typical 1/8 of an inch, will give you a flush condition when you install the strike. Let's see here now. They are giving us the location of those screw holes, which is what I was looking for. You've got 4 7/8 overall height. You've got 6 1/8 center to center on that stuff, on the holes that you'll drill in countersink. Drill and countersink for 832 flathead screw. They have a shim here. They're showing that you'll use the shim. Pressed metal nut. They've clearly not used those, no longer use those because they have just a couple of nuts in here. So they want you to secure the mounting tab with the nut. Just scanning to see if there's anything else of interest to mention. Now the wiring, it's DC voltage, so it's just 2 wires. There's nothing else to this. If you are powering it as simply as transformer through your switch to the strike, this is it. This right here, that's what we would call a single pole, single throw switch. That just represents your whatever it is, keypad, doorbell button, whatever you're using to activate the strike. That's what that is. That's the power supply. That's the load. That's the switch. That's the conduit. That makes up the 4 components to an electrical circuit. Load, switch, conduit, power supply. They're showing you how to install this with multiple strikes. Having one power supply for multiple strikes would be okay as long as you're not firing them all at the same time. That could be an issue. Which, you wouldn't be, really. The disadvantage of one power supply for multiple strikes is that if the power supply goes down, all your strikes go down. An individual power supply going down to an individual strike may be less inconvenient. They are showing you here how to reverse the function from fail safe to fail secure. If you want this always locked in the absence of power, you can indeed do that. You can switch this to fail secure, and that's where they show you how to turn the parts over in order to do that. You're just removing parts, apparently. Now, one interesting thing about Adams Rite strikes is you can tell what voltage the strike is by the color of the wires. I get customers that call and say, I need a strike. Okay, what voltage do you need? I don't know what voltage I need. Can you put a voltmeter on the power supply? And the next response is, what's a voltmeter? Well, just tell us what the color of the wires are. So we have 24 VDC, that we know. White stripe on black. That's wrong. This is or either this is wrong or the wires are wrong. This is a black stripe on white. That could just simply be a typo. Yeah, this document's pretty old, so they've probably corrected that. This is black stripe on white. Shows you the electrical profile, coil resistance, the amount of amps in a continuous application that you're pulling. Fail secure operation unlocks when energized. If power fails, the strike remains in a locked condition. That's not what this is. Fail safe operation locks when energized. So when it's fail safe, in order to lock the strike, you must energize it continuously. Used in applications requiring automatic unlocking in case of power failure. These are the voltage that the solenoid is available in. All right, let's see what else we have. Instructions, we've gone over. Template, it's not a template, it's a cut sheet. So what's important about this is it will give you an overview of the strike, showing you what it's compatible with. Okay, there it is. 1/2 inch to 5/8 projection, not 3/4. That's important to note. This won't work with a mortise exit device or a mortise lock. what I wanted to show you was this part of the part number here. That's what defines the configuration. We've got a 5, we've got a 1, 5 is what we have, fail safe. So it's 24 volt, DC, fail safe. That's what this client ordered. So now you can see how you would build the electrical profile of the strike based on that. If you have a pair of doors and the styles on the aluminum doors are radiused, you'd want a 7101. Finishes are here. This client ordered 628, clear anodized aluminum. And if you needed lip extensions, this is what they're going to, this would be the how you would alter the part number for the lip extension with this suffix. There we go. Let's wrap up this video on camera. Before we do that, there's a link below this video as seen here to the manufacturer's page within our site. And when we click on that, we can pull up not only all of the Adams Rite products that we sell by means of this horizontal navigation as seen here, but also a link to the manufacturer's website, as well as a link to the full product catalog. Let's wrap up this video on camera. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Now, some people might argue that these are the best strikes in the world. Some people might argue that they're the most awful strikes in the world. I think what we can all agree on is they might be the most common. These are... It's a grade 1 strike, so it's the same grade 1 strike as you'd have from a sister company of Adams Rite by the name of Folger Adam or Hess, more robust strikes. This is more of your garden variety material. Some people don't like these because they feel that they're not very predictable and reliable in high volume applications. Plus, locksmiths will tell me, or people that work on this material, this doesn't tolerate a lot of preload. If your door is not hanging in the frame true plumb level and square, it will put undue pressure on the inside of the keeper. They don't like to operate very well when there's that preload condition. It doesn't release. That's a complaint that I've heard from people about this Adams Rite strike. But when you consider the cost of this strike and the fact that they are grade 1, it's hard to make an argument against it. It has met the criteria for 1 million cycles, and it's awfully economical is the bottom line. Now, if you've got an application where it's going to take a lot of abuse or extreme high volume, I don't believe this is the strike for that application. You'll need a more robust mechanism. Folger Adams certainly has strikes that meet that requirement. Again, a sister company of Adams Rite. Very good technical support from Adams Rite. I've been contacting those folks for many, many years, decades in fact, and they're always very responsive. And to them for that, I say thank you. Any questions on the Adams Rite? This is their part number 7100-515 and a 628 finish, or any other Adams Rite product. Please feel free to reach out to us. And thank you.